Hey, all you science furries and everybody else out there pursuing knowledge, wisdom, freedom, and happiness. Scorched G Dragon here. A theory has been offered that this transportation system is nothing more than a loaded spring that was loaded with stored energy by pushing the car into place before starting. But this is not actually how this system operates. While true, it is possible to use two magnets like a spring by forcing two similar poles together, such as this. We have a north pole and another north pole. If I force those same faces against each other, that creates the effect of a mechanical spring. If I let go of that, it accelerates away. This system actually operates more like a conventional permanent magnet motor, such as a slot car motor or this fan motor here on the bench. And just like any permanent magnet motor, it does have cogging, which feels like little speed bumps as I turn the shaft of a rotary permanent magnet motor or slide the shaft of a linear permanent magnet motor. You can kind of see that has bumps. If I push that past one of those bumps, it goes to the next one. That's just the behavior of any permanent magnet motor. The magnets on this linear motor for the transportation system are all facing with south poles up. But in fact, there are also north poles facing up. As you can see with this magnetic pole detector, there are wide south poles and narrow north poles between the south poles. We have a pole detector here, and there's a nice wide south pole, but look at this, there's also a very narrow north pole. Same thing over here, wide south, narrow north, wide south, north, which is not quite as narrow. These are getting farther apart as we go down the first ramp here. So it just alternates between south, north, a lot like alternating current. So I see no evidence that in any theory the stator is a single field device pushing against another single field device such as this actuator, which as you can see also has north and south poles. On the actuator here we have, there's north, and we come over here and there's south. But this is where it started getting really interesting. As I was attempting to look at poles with the track in place, and the detector wasn't right on top of the magnet, I started noticing a very interesting effect here. As we start checking our poles, once again they're south, but then I get over here and, well, what's this? This should be a static magnetic field, but why is the detector acting like this? Why are we getting some kind of pulsation going on here? First I thought, well, maybe the sensor is just a little bit weak, it's not picking up the field because the field's kind of weak. But if I go higher up, it's actually stronger up here. I get down there close to the magnet, and there's just some kind of pulsation going on. I have no idea what the significance of that is. At any rate, let's go ahead and proceed with this demonstration. I'm going to go ahead and put the actuator in place here. I have to line up all 8 wheels on track. And somebody was saying, well, I need to actually push this actuator into place as if I'm charging a magnet or a spring. But sitting here on a level surface, if I simply let go of this, it actually pulls it to that very first cog. It just acted exactly like that. I can push it past this cog to the next one. Next field's not quite as strong, it's not as dramatic. It'll go away from the finger and center on that cog. The strongest one's over here right near the gate. If we go past that next cog, once again it pulls it in. And I can go ahead and pull it past this gate down to this position where once again there is no loaded spring here. It's just kind of sitting there all by itself without any load. Now I can kind of take advantage of that cog because I want it to kind of start on its own, so I'm going to go up the ramp against that one cog just a little bit. But that's not enough to actually accelerate this actuator all the way down 170 plus inches of track. In fact, when I let go of this, it moves quite slowly until it actually reaches this gate, at which point it accelerates out of there. So I'm just going to let go of this. Not quite enough. Let's try that again. I'm just going to let go. Did you see the acceleration? We'll go ahead and do that one more time. Let me get this back on the track. If we come over here to right about there, when I let go of this, it starts out slow and then accelerates on its own with nothing more than magnetic energy. So I'm going to let go of this. Did you see the acceleration? It actually accelerated on its own out of the stator. That is all for now. Kindest regards, Scorch. Hello everybody, Scorch Green Dragon here. Filming another update to the current Bedini, John Bedini pulse technology. This is both John Bedini and Tom Bearden, as well as Tesla and many other really good scientists out there. This one here is a 2-coil motor with 5 outputs and is now using neomagnets, as well as having the capability of having some shaft output on this. Over here we've got a potential 12-coil machine that could have 6 coils on each side, constructed just of Velemite and common off-the-shelf oil light bearings from Home Depot. Find them in the swamp cooler section. Same type of bearing that a lot of motors use. Over here in the workshop, I have just set up a interesting experiment using just the regular SSG wheel. The difference here is that the output from this wheel is not going directly to the destination battery. First, it goes through an induction coil. It's about 900 turns. Before that, charging power and energy is going to the destination battery. In parallel with that induction coil is a full wave bridge rectifier just wired straight across that coil. And with the DC pulse technology being used here, that DC pulse actually has the capability of generating additional energy coming out from that rectifier to a storage capacitor. As you can see here, it doesn't take very long to get from 12 volts up to about 60 volts before we can go ahead and use that stored energy in there in the form of a radiant pulse being sent back to the actual source battery right here. The source battery is powering the motors, providing about 1/4 amp to the motor, as well as a little bit of power to power an off-the-shelf timing circuit and another relay here. And those are actually taking the energy from that capacitor, which, as you can see, is charging rather rapidly as this motor runs. And it's going through an incandescent bulb over here to act as a buffer for the relay. And every time that relay fires, that pulse is going down to the source battery, which has been maintaining a very stable 12.6. It does change, every time that capacitor is fired into that battery. We see a good 14-15 volt jump sometimes, and of course there's additional energy output. Not only is the motor up here running and dealing with the friction in the bearing, as well as moving air. It's not a totally aerodynamic motor. It is putting out a breeze. Just as I stand here, I can feel it in my face. And then of course we do have that incandescent bulb, which is producing light and heat, just escaping into the environment. as the remaining energy goes back to the source battery. And I'm just going to pan back a little bit here, and we'll watch this cycle a couple times, and that'll be the last of this video.